Hello everyone and welcome to my YouTube channel. Today I am going to talk about the introduction of point cloud processing, and in this video we will talk about how to create, visualize point clouds. So first thing first, we will talk about in this tutorial about point cloud processing, and it is gonna be beginner friendly, so you don't have to worry much about the details, and I will walk you step by step into this, and I will try to make it fast as possible. So let's jump in. All right, so I had created a folder, and the folder I just named it as a point cloud 01, and inside my Visual Studio Code, and then I had created a folder of data and the other folder for output, and then the file is IPYMB. It's IPYMB in order for us to walk through cell by cell, so you don't have to get confused, and it's easy for you to understand the code, easy for you to troubleshoot. So let's start first. So the first thing I want to do is the first thing that we want to do here is we want to do pip install pip3 install. We want to open 3D. So that's what we want to install. So that's the first tool that you need here, and it's gonna take some time to install this tool. I will pause the video and get back to you once it's done. All right, so as I had done this before, so I have the requirements already satisfied. So as I want to talk a bit about the point cloud, it is used to be used for robotics, automation vehicles, and for assistance system, for healthcare, and etc. And it is the 3D representation for segmentation, object detection, and object tracking. So this is what we're gonna learn step by step. So the first thing we're gonna do is to import libraries. So we're gonna import Numpy as MP, and we gonna import matplotlib. So import matplotlib matplotlib payplot as plt, and we also want to import the open3D that we just installed as o3D. So these libraries, that's all what we need for now, and it is being imported. Move next. So now what we're gonna do is we gonna create a random point cloud. So the easiest way to create a random point cloud is by creating point cloud randomly. We usually don't do that unless we want to create some noise for GAN, or we call it the generative adversarial networks. So usually the point cloud is represented by m/3 because we have 3 axes. So we will create a random number of points by call it number of points. We're gonna create, like, for example, 5 points, 10 points, up to you. We're gonna create PCD, or what it called point cloud dimensions. So PCD we will call MP, which is the MPI that we just call it in the previous cell. So we will do random, and random we have to read that rand, and from random we gonna call the random point that we just created, the number of points, and we put 3 as number of dimensions, and then we do print for PCD that we just created, and then we just ran this cell. So we have 5 points randomly being created, and if we run it again, for example, let's memorize this number 443. If we run it again, we will have another different number because it's random generation. All right, let's move next. So we're gonna visualize these points. So we will do figure. In this figure, we will just put the AX and we will just PLT, which is a plot, dot subplot. We want to do a sub figure, and you will see why. And then we will do subplot underscore KW, and we will let it equal to projection, and I need to put it into two quotations. There we go. And we will let it be as 3D. And we will call the AX dot scatter 3D. And from here we have the PCD that we just called, and we will have our array, then PCD for 1. So this is for 1, and then we have the PCD for 2. Oh, I missed the semicolon. Okay, look good. And then I want to do the labeling for the figure. So the AX set X label. I always misspell this thing, so I will just call it X. And then the same thing I will do for Y, and same thing I will do for Z. So I will just copy and paste this one twice. So I will just change the labels, Y label and Z label, and X, Y, and Z. Set underscore, then I will set a title. So the set title, I will just call it random point cloud. And I will display that by displaying it. So I will just PLT the show, and that's it. I will just run. So I will have error, as you see. All right, so here we go, and this is our figure, as you can see, and there we are. So these are the 5 random points, and these are the labels that we create, the X, Y, and Z, and this is the title that we just create. It's a simple matter. So we go back to our code and we just close the plot, and then we create a new cell. Let's go next. All right, so sometimes the processing of 3D models directly, when you sample it directly, it will take memory and time. Therefore, we are sampling the points, the point clouds, I mean, from their 3D surface is like the potential solution. So what I'm gonna do, I have will download a bunny. So I will just call it bunny, and O3D data dot bunny mesh, and I will just create mesh and O3D. I need to change my keyboard. O3D. I don't feel good with it. Read. I will read the triangular mesh for the bunny.path. So I will just run this cell and we will get download the bunny. Or like the other way that we can just import the bunny by just creating mesh.o3d.io.read triangular read underscore triangular mesh from here, but I have it. I should put it in data move. So I have it. My bunny is in data. So I will just say double quotations data backslash bunny.ply, and I will just run that. And now let's display that. So we will visualize the bunny. So we will say mesh dot compute vertex normals, and we will just put the two brackets and then o3d dot visualization. I need to change my keyboard. Draw dot geometries, and that's it. Run. So we should see the bunny now. We don't see the bunny. There is something wrong. We should see the bunny. We don't see the bunny. My bad and my mistake that I didn't call mesh. That is the silly mistake. And there you go. This is our bunny. So as we can see, this is our bunny, our cute bunny. All right. So far, so good. Let's move forward. So for us to sample the point cloud, there are several methods exist in order for us to do that. So we will just put a number of points and then we will visualize it. So what we're gonna do, we just PCD, we will call PCD, and then we will call our mesh dot sample point uniformly. And then we will just set the number of points equal to, for example, I want to put a low number and I want you to see the difference when you increase that parameter. So we will do the visualization and then we will just display the bunny after we put all that 100 points. So we have visualization dot draw geometries for I will not repeat the mistake that I just did, which is PCD. And let's run it and we will see our bunny with the 100 points. So this is the 100 points actually. So what I want you to see is that I'm going to increase a 0 and then run it, and then I increase a 0, 2 zeros, and I will run it. So you will see how different is that. So from far, like, our bunny looks solid and beautiful. And if we increase another 0, it's gonna look so good. Yeah, you can't even tell unless you zoom in very much, then you will see the gaps between the points. Anyways, let's move forward. So we will save that output. As we can see that our output folder is empty. So we will just say o3d.io and write the point cloud. So right point cloud is here. And then we will have, I'm making so much mess with my beautiful keyboard. Output, I'm sorry, today, the topic of today is my keyboard. So we will say bunny underscore PCD TCD.ply and then comma PCD. All right, just run it. So here we go. Our PCD bunny is being saved. Moving forward, now we're gonna talk about the RGBD, or the data collection for RGBD used RGBD sensors, such as Microsoft Connect, and which is simultaneously provide RGB images and the depth of image. So RGBD sensors is involved in many applications such as indoor navigation and obstacle avoidance and etc. So here what we're gonna do now is that we're gonna create a point cloud from RGBD data using Open3D, and we will import like 2 images to create the RGBD images. And finally, we will compute the point clouds as I'm gonna show you. So first thing first, we're gonna create color row, and from color row, I will call the o3d.io.read. Where is that? Read image there. Read image. And from that read image, as I will provide you all what you need from this tutorial, I will provide the link below, so you don't have to worry about that much. There I am. Okay, so what do I have to read in data? We will gonna read the RGB.jpg, which is data /RGB.jpg, and we will need the depth, so we will call depth row equal to o3d.io.read, same thing, and data where is that? It is depth. I didn't put it here, so I'll get it to you in a second. I just didn't see it. It was there. All right, so from here I will just do RGBD o3d.geometry .rgbd image .create from, oh no, that is wrong. Create from color and depth, open a bracket, and then we have the color row, and we have the depth row, and we have the convert RGB intensity equal to false. And then we will use the RGBD image to create a point cloud. So from here, we will just say PCD equal to O3D dot geometry dot point cloud dot create from RGBD create from RGBD image. And what do we have? We have the RGBD image that we just created in the previous parameter, and we have the O3D dot camera. See, like seriously, I'm clicking everywhere. Don't pinhole camera. Yeah, this one. And dot the prime sense, where is that? The prime sense default. Yep. And close bracket. I think I made a mistake. Okay, now it's correct, and close the last bracket. So we have the yellow bracket and we have the pink bracket. Now everything is correct and all set. All right, so I need to do the visualization. So O3D dot visualization dot draw geometries, and I will not repeat the mistake, which is the PCD. Run. there is a error. Let me check my code and get back to you. Yeah, so as I expected, I was writing this line wrongly. So before I do run, let me show you the RGB image. This is the image that we have two boxes and table, and we will see how it's gonna look like when we run that. So this is how it look like in depth. So that is the 3D view of it. So here is the table. And here is the boxes, as you can see. So the points are like not there because it is not covered. It is not being captured. So like if you look at the image like that, you will find that it makes more sense, right? All right, let's move forward. All right, so in this part, we will talk about how to convert between Open3D and Numpy. Sometimes you need to use Numpy to visualize your models or your like 3D model, and sometimes you need to use Open3D. So in order for us to do first thing first, I will just create a random Numpy point cloud. So let's say number underscore points. Let me just say 2000, and then PCD underscore, just to differentiate the PCD. So I will just call it PCD numpy, and mp dot random there dot rand, just like how we did it last time. The first example that we did. So we have it in 3. So I will just run that, and we just created a number of points, which is 2000 points, and then we will convert to 3D Open3D point cloud. So I will just say PCD PCD underscore O3D equals to O3D dot geometry dot point cloud to brackets. So in this, we just created a point cloud object, and then we will just say PCD O3D dot points equal to O3D dot utility dot vector vector 3D vector, and we will just call the pcd.mpy, and we just had set the pcd.mpy as the point cloud of points, and we will just display that by saying o3d.visualization dot draw geometries, and then PCD O3D. All right, so we'll just run that, and we will see number of points, which is like 2000 points. If you increase that with another amount, so you will see that is how it's going to look like, and that is our points random. Okay, let's jump forward. Now we will jump from Open3D to Numpy by creating our first point cloud from .ply file by using the open3d.io.read, and then we will just create the function, and we will return Open3D cloud point cloud. So we will just read the PCD O3D. So we will just o3d.io.read point cloud, and we will just read our bunny, which is from data folder. We just have our bunny.pcd, and then we will convert that from open 3D to Numpy. So we will say PCD underscore Numpy, the one that we just created. So mpy dot as array PCD underscore O3D dot points, and then we will display using matplotlib. So we will just say fig as we did previously, ax plt dot subplots. So in these subplots, we will say subplot kw, etc., as we done last time. So here I have projection. So we will call the ax scatter 3D, and we will just call the pcd.mpy this one, and we will do the 0, 1, 2, and 1, and 0, 1, and 2 as we done previously. So we will have double dot 0, and then we will have the PCD, same thing for 1, and same thing for 2. So I will just save my time and copy paste this thing, and then in the last one, I will just remove the comma. All right, so let me do the labeling, and as we done, we will just do ax set x label, y label, and z label. So I will just do it once and copy paste. So set underscore I don't have a shortcut. I was looking for a shortcut. So x label, and let me write it to the end. I was rushing. So this is for x, and just copy the whole thing. And for y and for z, and let's fix them. So this is the z, this is the y, and this is the y, and x, y, z, exactly. So what we need else, and we just ax dot, we will just set a title. So set title, where are you? Set title. So set title, and then from the title, we will just have like our bunny, our dragon, or whatever. I will put for you all the examples so you can play with them as you want. Point cloud. And we will just plt.show. So you might feel dizzy. All what we done now is we display the bunny using Numpy. So we will just look closer to our beautiful bunny, and there is our bunny. And we just close that. So at the end of this tutorial, in conclusion, we had learned how to create and visualize point cloud. So by the end of this tutorial, we had learned how to visualize the point cloud. So that was the introduction. So if you are interested in these tutorials, see you in the next one.